During this video, we're going to have a look at the different types of scans that we receive at Orthotech Laboratory. 4 over here are using the laser scanner. You can see how different those scans are: weight bearing, semi-weight bearing, semi-weight bearing, and non-weight bearing. Here we have the Orthotech 3D Mini. Here we have a $20,000 engineering scanner, accurate to 0.2 of a millimeter. And here we have 2 iPad scans. One has been recently calibrated, the other one hasn't been calibrated for a couple of years. So we're going to talk about the different scans. Starting with the laser scanners, the bottom right here is a full weight bearing scan. Problem with full weight bearing scans is that the soft tissue compresses up against the glass. So we have a flat transverse arch, flat lateral arch, flat heel, and if we were to make an orthotic true to that data, most of it would be flat and you'd have a small raise in the arch. Most podiatrists aren't looking for that in their orthotics, so most laboratories will round out the heel, create a small lateral arch, create a small transverse arch, and there's a lot of extrapolating and guessing. It's good for shoe manufacture because, or custom shoes, you get the soft tissue expansion, forefoot widths, heel widths, but it's not that great for making custom orthotics. Semi-weight bearing here with the heel and forefoot lightly touching the glass, you'll still see that the rear foot and forefoot are completely flat, as is the lateral arch there. So we get a tiny little rise subcuboid, but it's not very high. So again, there's a fair bit of extrapolating of that data and working with averages and rounding that needs to be done to deliver the podiatrist something that they're expecting. Some podiatrists still use a technique where they put the forefoot flat on the glass and lift the heel. Problem is that you get a distortion in the lateral arch. So if we are to bring the heel back down to the ground there, the forefoot then sits elevated, and that's not really what the forefoot looks like. That is actually the same foot as that, and that, using different scanners and different techniques. So on this scanner, the lowest point appears to be 5th ray substyloid, whereas non-weight bearing, this person has quite a good lateral arch, styloid sits quite high. So semi-weight bearing with the forefoot on the ground, semi-weight bearing forefoot and heel, and full weight bearing aren't that good for orthotic manufacture. You can use the laser scanners in a non-weight bearing scenario that gives us good foot data and true data. Moving across to the engineering scanner, so this one here is worth about $20,000 and is accurate to 0.2 of a millimeter. You can see how much data we collect. You can see the medial lateral malleolus, the curves in the Achilles. Really good data. You can't hold the foot in neutral because you've got to be too far away from the foot, but I introduced this one just to show you the number of pixels that are in a 0.2 millimeter accurate scanner. So this is the Orthotech 3D Mini. You'll see that we capture transverse arch, transverse arch, transverse arch here. So there is a slight forefoot supinatus, slight plantarflex first ray, but with any of the non-weight bearing scanners, you should be capturing transverse arch and lateral arch. So if I just turn the pixels on here, you'll see these pixels are fairly closely knitted together, especially when you compare it to an uncalibrated iPad scanner. So you can see how wide those pixels are versus this, but it's not going to be as good as an engineering scanner worth $20,000. So you do get what you pay for. So if we just turn these off, so one of the reasons we still recommend the Orthotech 3D Mini is that it's accurate and you can hold the foot in neutral. The iPad scanners, they're accurate to about 4 millimeters if they're calibrated regularly. They are accurate to under a millimeter if the iPad doesn't move and if the object that it's scanning is within 30 centimeters. But when you bring it out to 50, 60, 70 centimeters to scan the foot can move because you can't hold it. The iPad can move. The accuracy is about 4 millimeters. Now that seems to be okay for a lot of podiatrists. So if you're comfortable with that accuracy level and you're comfortable not holding the foot in neutral, then it's a good scanner as long as you calibrate it regularly. If you don't calibrate it, then we end up with images that look like this. Distances can be off, widths can be off, and often the orthotics can be wrong. So our recommendation for scanners are laser scanners, non-weight bearing, the Orthotech 3D Mini, which is non-weight bearing, or the iPad, but you must keep it calibrated and you must be happy with a 4 mil accuracy and not being able to hold the foot in neutral. Thank you.